Alright, so today what I want to look at is solving some other types of trig equations. Yesterday we looked primarily just at linear ones, or ones in a linear form, and we didn't have any kind of mixtures of trig functions or anything like that we have to deal with. Today what I want to look at, though, is dealing with ones that have more of a polynomial form, and then also start looking at a couple that have mixtures of trig functions and some various ways that we can handle that. Alright, so the nice thing about this, though, is that what we talked about yesterday with the general strategy will still apply. Okay, so far we haven't had to do any of part one.
Wait, general solutions or general strategy?
General strategy.
I remember.
Okay, we had, and this I just gave you, this isn't something you need to memorize or whatever, but this is just a good strategy to use to help you solve them, especially if you see one and you're not sure what to do. Kind of going through a checklist like this can help you at least get started. So I want to look through, first of all, an example of a polynomial equation involving trig functions, and I want to relate it to things that you've done in the past, okay? Hang on, that got in the wrong order somehow.
It's similar on mine.
There we go. Sorry, I must have dragged it accidentally. Okay, so here we have a problem. We want to find all the solutions of 2 sine squared x minus sine x minus 1 equals 0 in the interval from 0 to 2 pi. So you'll notice this is in a polynomial form, or we could say more specifically a quadratic form, because we have that sine squared. So what I would encourage you to do is to keep in mind, how do we solve quadratic equations? There's usually one of two ways. Huh? Quadratic formula would be one of them. What's another? Or you can factor. Okay? So here's the thing. We can treat this equation initially just like this. 2y squared minus y minus 1 equals 0. Okay? And you've been doing those types of equations for a long time. Okay? We have 2 times something squared minus something minus 1 equals 0. And by the way, if it's helpful for you to rewrite it like this, to do the factoring, that might be something you want to do. Okay? Now, let's remember how we factor polynomials. Okay? When I have a trinomial like this, I'll write down my 2 sets of parentheses. I usually start by splitting up my y squared into a y and a y. And then I see this is a minus 1 here, and the only way to get a minus 1 is to multiply a positive 1 by a negative 1. Okay, so I know the second terms have to be plus 1 and minus 1. Now I just need to figure out how to get the 2 in front of the y squared. So the 2 is either going to go here, and then a 1 will go here, or the 2 will go here, and the 1 will go there. Alright? The key is, one of those will give me a minus y in the middle, the other is going to give me a plus y in the middle, so I got to get it right. So I'm going to put the 2 here, the 1 there, so I'll have a minus 2y plus y gives me the minus y in the middle. Alright, and I know some of you have a little different strategy for factoring those, and that's fine, but that's kind of how I think it through. So now that we know that that's how this would factor, we can actually write this in its factored form. Okay, but instead of y's, we have sines of x. So 2 sine x plus 1 and sine x minus 1 are our two factors. Okay, and again, I'm relating it to the algebra just so you can see there really isn't much new that we're doing here with these types of equations.
Can we do the rainbow method?
It's called the Bob method.
You can use whatever method you want to factor. We're not going to go through it again. Okay? But you all know how to factor. Okay?
Do we separate the 1 in terms of sine and x squared and that?
I'm sorry, separate the 1.
Yeah, like, you know, 1 equals sine. No, never mind, because I'm cosine of 2, right?
Oh, like do a 1 minus cosine squared equals sine squared?
Yeah.
We wouldn't in this case because this is sine. We want to keep it all one trig function. Okay? Now, think back to how did we figure out the answer once we had this factored?
You set both equals to 0.
Yes.
Yeah, we would have, and eventually you guys were able to just look at it, write down your answers. But when you first started, you would usually write out the 2. Either 2y plus 1 has to equal 0 or y minus 1 equals 0. Because you have these two multiplied together and it equals 0. So you know one or the other has to be 0. Well, that's important to remember as we try to solve this. We're going to do 2 sine of x plus 1 equals 0, or sine of x equals, minus 1 equals 0. Okay? And at that point, we simply have 2 problems just like the ones we were working with yesterday. Okay? So it's just 2 problems in one now.
So the answer would be.
So now you have to do like the inverse of it.
Yeah, now we need to get sine by itself. So here sine of x is a negative 1/2. Here sine of x is 1. And now we're using inverse trig functions, okay, with our unit circle in this case. So we want all the answers from 0 to 2 pi. So what's our solution for when sine is negative 1/2?
11 pi over 6.
Okay, 7 pi over 6 and 11 pi over 6. Because we want the third and the fourth quadrants. Okay, so those are our 2 solutions. When sine is negative 1/2. Where is sine equal to 1? Pi over 2, or 90. Okay.
But couldn't you also say it's like just add 2 pi to it?
We could.
But it just.
In this case, we don't have to because our interval.
Okay. Alright.
So, if we wanted a general form, we'd put that plus 2 pi n for the general solution.
It's like, it's just exciting.
Good.
Because there's like so many steps, it's like, what? But then you like, you know.
Well, there are a lot of steps, but think about it. You learned most of the steps back in Algebra 1, right? You learned how to solve quadratics back in Algebra 1. Now, it's just instead of y's, we have sines. So you have one more step you have to do at the end.
So if it was like sine of x equals something that's not in the unit circle, you would just do inverse sine in your calculator?
Yes.
But then how do you find the other, that one's reference?
You could do it in the same way. I mean, if you had sine of x equal to negative 0.8, let's say, you would take the inverse sine of that, and is that 53.1?
If it
I
is,
think it's a 3, 4, 5 right triangle. I think it's 53.1.
wait, you do what you want.
What is?
You want
Okay.
the inverse sine
Of negative 0.8. I think 53.1 will
It
be
is,
a
well, it's
reference.
negative 53.1.
Negative 53.1, okay. Alright. So,
that's in that. What?
that's in which quadrant?
The second?
No.
No.
Or,
The fourth quadrant.
Oh,
Oh, cause it's
Okay.
300.
how'd you get sine of x equals -0.8?
He
I just
did
made
it.
up a new problem.
Oh, okay.
She was asking, what if it's not on a unit circle?
You plug it in.
So you plug it into your calculator, inverse sine or arc sine of -0.8. Your calculator is going to give you this, because remember it uses the range for arc sine of -pi/2 to pi/2.
Okay, so it's really 307 degrees.
So yeah, that's really, that's 53.1, which actually tells us our reference angle, but we want an angle between 0 and 360 in this case. So yeah, 306.9 degrees would be there, but then you'd ask yourself, okay, where else is sine negative?
The third one.
Third quadrant, so I would do a 53.1 degree reference angle
That's your angle.
there, so 180 plus 53.1 would give me 233.1. Okay, so in this case, those two would be my answers. Alright, so it's the same process, it just doesn't fit the unit circle, so we have to think a little harder. Alright. Alright, good questions though. Okay, we're thinking, that's good. So what do we do when we have equations that have different trig functions in them? Okay?
It's like having an X and a Y.
Kinda, except
The sine.
we have trig identities that often allow us to change those x's into y's. So we have all the same variable. So here you see we have 2 sine squared x plus 3 cosine x minus 3 equals 0.
Sine squared x equals 1 plus cosine squared x.
Close 1
Well,
minus. Okay? So yeah, we're going to use the identities that we've learned to get everything in terms of cosine. Alright, so we now have 2 times 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. And now we're back to where we were at on the previous one. We have a quadratic equation that we have to solve. Okay? So why don't you guys take it from there? Okay?
She was about to.
Is out how?
Well, how do you solve a quadratic?
Yeah, but how do you do the minus the 1 minus? Or
Well,
do you just put him in after?
Simplify first, right?
This should be.
No, simplify first.
what?
You want me to distribute the
Feel
two?
free to
That's what I did.
phone a friend next to you if you need for help.
Oh, and then you can do like.
Yeah.
Okay. Jesus.
Oh, wow. I'm gonna stop I'm thinking. Yeah. Mm-hmm. No. Pretty sure our method doesn't work.
The rainbow method never not works.
That's not true. It didn't work for the
I
last one.
cannot believe you just said that.
Never not.
You have to make it
positive.
It always works.
There you go. Didn't work for the last one.
Yeah, it did. I was really confused. Wait, it worked for me.
No, because you could not tell which to divide out. It's 1 and 1.
This one?
I just.
The last one.
No, I'm looking for.
They're a little trick
No.
factor.
No, because you would not know.
Just make it
It would
positive.
be 2 sin x
Three
minus
and
1.
two.
You would not. You would not know. Yes, it would be.
Yeah, I would do that, Derek.
That's exactly what you get, right? 'Cause you multiply this over, you get
No.
negative 2.
You would get, negative.
It does make your factoring a whole lot easier if you get rid of any leading negatives.
But you could,
See?
You
How
can
much-
do it
how
cause so
much-
long as you multiply everything by
Yeah.
negative, cause 0 times negative 1
But
is
you could
still
also-
0.
Could you also get negative x plus 1 and then negative 2x plus 1 as your,
You're always so
I
confused.
Does
thought
it
this was
matter?
different.
What?
You wouldn't have both of them negative, cause that would have made a plus 2.
Nico gets offended.
You're
yeah,
just confused. This is really stupid.
because if
Wait,
you
can you
do,
put names?
You said
because if
I-
you
I
Can't
am
remember.
always like my personality is.
you get 4 pi over
Hey, let's
3
look at the factoring here, cause some of you guys, here's the thing, some of you guys are still struggling with factoring and it shouldn't be. Okay. And I think part of it's cause we've got this method that is decent, but I think if we just thought about it, it might be better.
Wait,
Okay?
how did you do?
No, I got
So,
it. It works fine.
I've got a cosine squared. There's actually only one possible way to factor this. I've got the cosine squared, so I'm going to put a cosine and a cosine.
Why are you allowed to get rid of
Okay.
all the negatives?
I multiplied everything by a -1 on both sides of the equation.
Okay.
Okay? Now, I see I have a +1. The only possible way to get a +1 without using fractions is to multiply a +1 by a +1 or a -1 times a -1. Okay? So which one do we want? Well, there you look at the middle term. We need to have a -3 cosine in the middle. So I need a minus and a minus to make my +1 in order to have a chance of getting minus in the middle. Alright? So look at the second sign. That tells you if these signs are going to be the same or different. Since it's positive, I know these have to be the same sign. And then you look at this sign to tell what it is. They've got to both be negative. Okay? Then the last thing is to make sure I get this 2 in the front. So I'm going to have a 2 cosine and a 1 cosine in my parentheses. And if you double check, you have a -2 cosine x, -1 cosine x. That's a -3 cosine x. Okay?
So now it's,
The Bob method is the way to go, Mr. Hickson.
yeah.
I'll learn it at some point, I
Can
guess.
we teach it to you
Yeah,
again?
can I do it?
Not now.
It's not
Okay.
that hard. You just multiply a times c. And then
So, what's cosine from the first set of parentheses? What does cosine equal?
1 minus x,
A half.
1
Okay. And from the second set of parentheses, what does cosine equal? Alright, cosine equals 1. So, where is cosine a half? Pi over 3.
wait,
Which quadrant is cosine positive in? First and fourth, that sign. First and fourth.
Yeah.
So this would be what pi over 3?
pi over 3 is
Good. 5 pi over 3.
oh, it's 2x minus
Sure.
1. It's x minus 2 and 2 minus
5 pi over 3.
1. No, it's x minus 1.
That's disrespectful there.
Do you
Okay.
want 0 or 2 pi?
Well then cosine
So how do you get
cosine equals 1 at
2 pi or 0.
0 or 2 pi. Now let me point one thing out here, okay? If you're given the interval, notice how they write the interval on this.
It's okay to
See how it's a half open interval?
Yeah.
So technically you could just put 0 as your answer. You don't need to put the 2 pi because see the parenthesis, 2 pi is not included in the interval.
X minus
Yeah.
1 and 2x.
So, and that's because these are the same angle. It's just they're coterminal. Okay, so we could just say 0.
Then when you
All right.
Mr. Nixon, if in the parentheses, like where you have 2 cosine x minus 1, if my numbers are different but I got the same answers, okay? Because I just, well, same numbers but different
This is
signs.
possible.
So that's negative 2. So it's negative.
Oh, because you didn't factor out the negative at the beginning. That's fine. Yeah, it will look different if you. All right. So does everyone see how we got those 3 answers?
Yeah.
Okay.
That's
Next. There are cases where we don't need to, and in fact can't, get it in terms of one trig function. Here's a case where there actually isn't a good way of getting it all in terms of one trig function without doing something that's not allowed, okay? When you had equations like this in algebra, x squared equals x, what was probably something you were tempted to do?
You.
Divide by x.
Huh? Divide by x, yeah, okay. You were tempted to divide by x and make that, oh, well, just x equals 1. And then you plugged it back in and you said, well, yeah, 1 squared equals 1. But what ended up happening?
2 squared does not equal 2.
what?
Well, that's true, but
Cool, yeah.
we
Yeah,
never said x equaled 2.
You got it.
What kind of equation did we start with?
Quadratic.
Quadratic. How many answers should we get? 2. What's our other answer?
Minus 1.
Not 0.
0. Now, someone tell me, why are we not allowed to divide by x?
You can't divide by 0.
Because you can't divide by 0, and we lost one of our answers. Okay? Well, the same thing holds true here with our trig. You don't want to divide by a trig function, okay, to cancel it out. Now, it is possible to divide, like if you had sine on one side, cosine on the other, divide by cosine and make it a tangent. Because then you still have that idea where cosine can't be 0. Alright? But in this case, we wouldn't divide both sides by cotangent.
Can't you just switch all these to like what?
Just move the cotangent to the other side and then
Okay.
make it to 0.
Alright, so that's a good idea. We see we have a quadratic. We're kind of stuck on part 1, so let's skip to part 2. Treat it like a quadratic. Set it equal to 0. Okay, so cotangent x times cosine squared x minus 2 cotangent x equals 0. Okay? And now you might see something you can do.
Subtract.
Cotangent.
Oh, 2.
Wait, what?
Cotangent minus 2 cotangent.
Like the factor out of the tangent.
Okay, there we go. I think, is that what you said? I couldn't tell. Alright, we have a common factor here of cotangent. So I'm going to take that out. Cotangent x times, what's left? Cosine squared
Minus 1.
Minus cotangent.
minus 2. Come on, erase. There we go. Minus 2, and that equals 0.
You said them both.
Okay.
Cotangent
So
is-
yeah, now they're both equal to 0. Cotangent x equals 0, or cosine squared x minus 2 equals 0. Alright, so try to find your answers from there, then,
I don't know.
because we're back to yesterday.
It's like, how do you know the answer?
No, because
Answering the question.
I got cosine of x equals plus or minus root 2. That's not on the unit circle. Or is it?
Oh, sure it's in the unit circle.
It's not on the unit circle.
It's just
It
not.
would be 2, it would be root 2
I'm
over
sure
2.
it is on the unit circle.
Okay,
It's
I'm
not-
sure it
it's-
is. You guys-
it's not
I bet
on
you
the
two
unit
over
circle.
two.
It's not
Yes,
on
that
the
is what
unit
I'm
circle. It's
talking
just not
about.
on the
Root 2
unit
over 2
circle.
is 45 degrees.
That's
I
true.
know.
But this is a root 2 over
Yeah,
2,
it's
is
just
it?
root 2. That's why I'm
All right.
sad.
let's see what you got. Let's look at that one first since it came up. Hey, what's the value of the square root of 2 as a decimal?
What's it?
Let's start something square root of one.
No, it's 1.4.
Oh,
there you go. 1.414. Alright, so question, when is cosine equal to 1.4?
Never,
Why not?
because it's -1 to 1.
Exactly, remember your range for cosine. Okay, there you go. There's no solution here from that portion. Okay, now that doesn't mean there's no solution for the equation, it just means this part, cosine's never going to be bigger than 1 or less than -1. So we don't get any answers from that half.
Oh,
Okay?
-1 to
Where's
1.
that from?
What?
That's
From -1 to 1.
-1 to 1, yeah, think of your unit circle.
And all the others are.
Furthest away it is 1. So now cotangent, in order for cotangent to be 0, what has to equal 0?
Cosine over sine.
It's cosine over sine,
It has to be 0 over 1.
so that means cosine
Used to be 0.
must be 0, right?
Sine needs to
So
be 1.
pi over 2, 3 pi over 2.
Pi over 2 or 3 pi over 2, okay? Pi over 2 or 3 pi over 2. Those two quadrantal angles, 90 and 270. Or where cosine is 0. You could also think of it in terms of, alright, if cotangent is 0, that means tangent's undefined, so where's tangent undefined? It's just a different way of thinking about the same thing. Yeah, Yash?
So if it's like, say you get in cosine, it's like cosine of x is like 1.17, and then sine of x is like 3 or something, and it's equal to 0. And then you multiply that by 0, and then you multiply both sides by 3. 1.17 doesn't equal 3, right? I mean, it doesn't equal 0.
That's true,
Because cosine
but
can't be 1.1.
cosine can't be 1.17 and sine can't be 3 because they'll never be bigger than 1.
Sine, the range of sine is also -1.
Yeah, remember graphing it, guys? Sketching that. This is partly why I had you sketching those graphs. It goes down to -1 and up to 1. Okay? So. Alright. Let's take a look at one more. Alright, this is the last one yeah, this is our last one here. There are two ways we could do this one, okay? One way we can do by hand, but we have to be careful at the end. And then the other way is just using our calculators, okay? How can we solve any equation by using our graphing calculators?
By graphing it,
By graphing what?
the equation.
I'm just throwing it out.
Two equations and the intercept.
Okay. Graph each side of it, and then use the intersect function on your calculators. Okay? Here's the thing, and guys, this would be helpful to remember, even like as you guys take ACT or SAT in the future, if you got this big long equation that you know is going to take you forever, all that matters is your final answer, right? So that's one thing you can do, is use your graphing calculator, graph both sides of the equation, and use the intersect function on your calculator. Okay?
How would you solve it if you weren't using a calculator?
If you weren't, you have to kind of use a little bit of a trick. Because the only way sine and cosine are related,
This is their square, right? So you'd have to square the whole thing?
yeah, okay? The only way they're related is either by sine over cosine being tangent, but then that's not going to work here, or with the Pythagorean identities. So what we do is actually take both sides and square it. Now the danger to this is that anytime you square both sides of an equation, you're changing the degree, and therefore you could introduce what are known as extraneous roots. Okay, so we'll go ahead with this, but then we'll take a look and double check to see if we got any extraneous roots at the end. Okay, and we'll do that by plugging our answers at the end back into the original equation. All right, so let's look at this. We have cosine x plus 1 squared, so that's cosine squared plus 2 cosine plus 1, and that equals sine squared. What do you think we ought to do with the sine squared?
Change it to cosine.
Yeah, there we go. Let's change it to cosine by making it 1 minus cosine squared. That was the whole point of squaring both sides, is so we could then use that Pythagorean identity. Okay? Everyone understand at that point what we did? Okay, so now we have a quadratic equation. You solve it by getting it equal to 0, factor, or use the quadratic formula. Okay?
So, if you got them like both squared, like I didn't know you could do that to an equation.
Yeah,
As long as you do the same.
No, I know.
you're allowed to square root both sides, right?
Yeah.
You just have to be careful because, like I said, you can introduce solutions to an equation that weren't part of the original equation.
With the plus or minuses.
That and just because you're changing the degree of the equation. It's kind of like when you had rational expressions, if you multiplied both sides by an x or something like that, you could introduce more solutions. Just like earlier when we divided by an x, we lost possible solutions. Here you could introduce them. So that's why we just double check at the end.
Can you just cancel everything out to 2 cosine x?
Well, let's see. We got 2 cosine squared x, because we add this over here,
Oh yeah.
plus a 2 cosine x, and then 1 minus 1 is 0. Okay? So we actually can factor this.
We can take out 2 cosine.
Good. And cosine x plus 1 is left in the parentheses. Okay? So that means the 2 is irrelevant.
So cosine 0.
Cosine is 0. Where is cosine 0?
Add pi over 2 and 3 pi over 2.
Good. Pi over 2 and
4 pi over 2.
that's 2 pi. 3 pi over 2. Okay? Or cosine is negative 1. Where's cosine negative 1?
Pi?
At pi. Alright? So now what we need to do is double check those answers. Okay? So we check those answers. For pi over 2, let's see. We have cosine of pi over 2 plus 1. Does that equal the sine of pi over 2? Well, what's cosine of pi over 2?
What do you call it? That number.
0.
0. Okay? So 0 plus 1, what's the sine of pi over 2?
1.
1. So that works. Okay? Now, what's the cosine of 3 pi over 2? 0. What's the sine of 3 pi over 2? Negative 1. Okay? So if I tried that,
Getting there, man.
again, I'm questioning this. Does it equal the sine of 3 pi over 2? Okay, again, from our unit circle, that's 0 plus 1. That does not equal a negative 1. So that is an extraneous root.
Oh, because we squared it and stuff.
Yeah, when we squared it, we opened up the possibility of that happening. Okay? So then, lastly, we have pi. Cosine of pi plus 1, does that equal sine of pi? Well, what's the cosine of pi? -1. What's the sine of pi? 0. And that is correct. -1 plus 1 is 0. So, we do have two solutions, pi and pi over 2. Okay?
Why would we plus 1?
Why the plus 1? I just went back to the original equation.
Okay.
Okay? So if you do anything like that, where you're squaring both sides or multiplying both sides by a particular trig function, you've got to be careful and you've got to check your final answers. Okay? So, alright, so that's it. That's all I've got for you today. I gave you a few to practice with. Okay? There's a few different sections. So at least do, a couple from this section, do a couple from this section. One thing I will say, your book makes a big deal about putting it in your calculator to verify your answers. You want to practice one or two of those, you can. This has you just by doing it on the calculator, period, but use the opportunity to at least try to get algebraically. And just looking at those, it is possible with those to get it. Now the last couple get challenging. Alright, but it's possible to do those by hand. Okay?